Hello, Professor. This is for change. This is Stokes theorem uh, equation. I'm going to go ahead and use this Stokes equation to attack this problem. So the Stokes theorem basically says that the surface area of the curl of f dotted with the n, the normal vector ds, um, will end up giving you the curve of c, which is the boundary of the plane. So the first thing I did, I labeled the plane. I ended up solving for z because I knew I needed that first. Um, so I have that out of the way. Then I focused on the curl. The curl was uh, the curl of the vector field is f is just the cross product of the del and the f of x field that I ended up putting over here to the side. I'll go ahead and go back to that in a moment. The next thing I did is I put my vector field inside, and I ended up getting these variables. Again, I solved for z, ended up putting z inside. Then I put my partial of x and my partial of y. Um, I ended up giving these two counts, which is 1, 0, -1, and 0, 1, 1/2. Um, after that was set, I went ahead and started working on the cross products. So whenever I have a little bit of a interesting cross product that I don't know how to necessarily do, I use the IJK hats to help me out to label everything correctly. So I ended up getting, again, these parcels ended up canceling out to zero, partial of y, partial of z, zero, partial of z, x, zero, partial of x to z, zero, partial of z to x, zero. The only one that ended up pumping out something was the partial of x of e to the negative x, which ended up being incorporated into the bottom. And then I just ended up getting that variable out. The following one would be y partial of y, zero, and that ended up being zero. So then I have my total. Now I need to dot my partial of x and my partial of y. These were constants, so I just punched them out. This was the set that I ended up punching out. However, unfortunately, the normal was not, and I repeat, was not incorporated into this equation sheet. Not equation sheet, into equation set. So I went ahead, went back, and now to make it a joke. This will be incorporated back into so sorry, I was just wasn't loading fast enough. So the problem is, excuse me, going back to the previous statement, is that I did not incorporate the normal vector that I just recently forgot about, being brought up in class and vectors. So yeah. So now I incorporated the normal vector. The normal vector ended up puncting out to 2/3. Now I'm gonna go ahead and keep the same integration sheet that I had and just add that constant afterwards. Um, which ends up being shown on this previous set that I'm going to go ahead and insert one more time. But I'm going to go ahead and continue on with this side just to finish it up. So the integration now has left over the bounds. So now we got to incorporate our bounds. Since the function is of y and z, I mean of x and y, I can go ahead and make my domains into bounds. The height of y is 2. So I just went ahead and distributed that, and I distributed that, made a function of y in terms of x, and now I can go ahead and integrate in terms of my d to y. So I inputted that into our domain, ended up getting negative e to the negative x dy dx. That, and then I went ahead and integrated that first part, which ended up just giving me my y. I incorporated that y. Now I have the integral of 1, 0, negative e to the negative x, 2 negative x dx. Integral of 1, so I inputted my e to the x, split the integral using the plus signs. Now that I have that, you can go ahead and integrate between the two steps. The integral of negative e to the negative x, e to the negative x is negative e to the negative x, plus negative e to the negative x, which is second integral. I input my values for 1 and 2, so I get negative 2, negative e to the negative 2, minus negative e to the negative 0, plus negative e to the negative 1, minus e to the negative 0, and then getting negative 2, minus e to the negative 1, minus e to the negative 1 plus 1. That set ends up being e to the negative 1 minus 1. Then the final step is to incorporate that 2/3 from the normal, the constant, back into the equation. Finishing off, I ended up incorporating the normal vector inside after all the distributions. Next 2 to e to the negative 1 divided by 3 minus 2 divided by 3 will end up giving us our answer, because this would be my final set, and this would be the final set distribution. Thank you. I appreciate it.